Okay, so 3.2 is building more of these logical statements. What's an and, what's an or, uh, what's an if-then statement. And so this is another kind of, we're building into this idea that we'll eventually get into truth tables. We'll eventually get into, I don't say we're going to get into arguments, but we'll be able to kind of dissect arguments and kind of put the pieces together and say, oh, actually what you said is not a true statement, or, oh, actually what you said is true. So we're going to build off of that. Remember last section we talked about statements, we talked about negations, and we kind of talked about this idea of quantifiers, which is a little bit kind of the trickiest thing in that section. So we're building on those concepts. And so in the last section we talked about how once we get this idea of statements down, and once we start actually working through examples with statements, we like to kind of assign a letter to the statements. And typically with logic, for whatever reason, I'm sure I could probably look up why, we tend to kind of start with P and Q. And so we have two statements here. P says it is after 5 p.m. Q says that they are working. So we want to write each compound statement below in symbolic form. So compound statements just means we're going to take statements, try and put them together somehow. So in this case, we have is after 5 p.m. and they are working. And so the symbol for and is an upward facing V, which looks probably similar to something that we saw in set notation with an upside down U. It's just now we're not dealing with sets, we're dealing with statements. And so upside down, or a caret, upside down V, that is the symbol for and. So if I was to write this in symbolic notation, I would do P, I guess symbolic form, I would do P caret Q, P and Q. Now to do part B is the exact same question as part A, except for notice that at the end it says not working versus working. So building on the concept that we did the last class period, we know that tilde, or that wavy symbol Q, means not. And so my answer for this is going to be P upside down caret, or caret upside down V, tilde Q. P upside down V tilde Q. I think I'm going to stick with upside down V for this. And so there are a lot of English statements that we use and, but don't use and confusingly enough. Like we say different words, but we mean those two things are and, they're together. And so and is obviously one of those relationships, but is one, yet is, nevertheless is. So it is after 5 p.m. and they are working is logically equivalent to it is after 5 p.m. but they are working. Yes, in English language that has a certain different connotation, but as far as combined statements, we're saying this thing is happening and this thing is happening. Maybe we don't like that second thing is happening, but that second thing is happening. And so that's the idea, is that if we are going to see things in these, if we're going to see these logical or these compound statements with the upside down V or the, we're going to see or and if then, that doesn't mean there's only one way we can represent things. There are a lot of different ways to say these things. As far as this course is concerned, though, I'm not going to throw something at you that isn't, like if I'm looking for an and statement, I mean, I'm probably only going to just use the word and, but I wouldn't use anything outside this table, where I bet if you spend some time kind of thinking about the English language, there's probably maybe a couple more you could come up with that is a logical statement of and, but isn't that exact word. So let's see some of this in practice. So we have here P and Q representing P is the bill receives majority approval. Q is the bill becomes law. We want to write the following compound statements in symbolic form. So this is actually pretty similar to what we did on the first slide. Oh no, we're doing a new equivalent symbol. So I'm introducing a new equivalence, which you might be able to gather from these statements. So instead of having an and, we have an or. The bill receives majority approval or the bill becomes law. The bill receives majority approval or the bill does not become law. Well, if you recall set theory, you might be able to guess what the symbol for OR is. Well, it's kind of just a regular capital V at this point. So to write the first statement, if P is the bill receives majority approval, Q is the bill becomes law, then statement A is P, V, Q. And the second statement, very similar to the AND example, is the bill receives majority approval or the bill does not become law. That is P, V, tilde Q, or squiggly Q. Now, I feel like in general, people are pretty good at grasping what an AND statement and what an OR statement is, and also when those things are true or false. It's pretty doable with an AND statement. If one of those things is false, that they're both false. If for an OR statement, both of those things are false. In order for it to be false, we'll talk about that more next section. But if-then statements are certainly statements in the English language that we use, I don't want to say all the time incorrectly, but we're very loose about them. So for example, this isn't even the example up there, that if I were to tell you, if it is raining outside, then you need a umbrella, you might think, okay, well, if it's not raining outside, then I don't need an umbrella. So we almost treat it as an AND statement or an equivalent statement, but that's not true. So again, if it's raining outside, then you need an umbrella. Well, maybe there's another scenario you would need an umbrella. Maybe it's lightly snowing out and you still don't want to get wet. So that's another case where it would work. So if then, although it seems like it's the exact same thing as an AND statement, it is not. And we will get into all of that more in the next section. I just wanted to kind of create the difference right now. Make it clear one thing is not the same thing as the other thing. And so the symbol for an if-then statement is this arrow. So if I have a statement here that says, let P and Q represent the following simple statements. P, a person is a father, Q, a person is a male. Then if I wanted to write, if a person is a father, then the person is a male, then that person is a male. You do P, arrow, Q. Or if I wanted to say if a person is a male, then that person is a father, then it seems like these are the same thing. If this was an AND statement orders doesn't matter. So these would be the same symbol. Here order does matter. So A and B are very different statements. They're very different symbolic forms, or I guess compound statements, if we're going to be a little bit clear. And so just be aware of that. And again, this isn't meant to kind of put any political opinion on anything about gender or anything like that, because I'm not claiming any of these statements are true or false. I am just claiming whether or not these statements are statements, whether or not I can kind of represent things in a logical form. And then finally, if I wanted to do, if a person is not male, then that person is a father, not a father, then anytime we see not, we have that tilde, we have that curly Q. So that symbolic form would be tilde Q implies tilde P, or arrow. Anytime I say implies, that's the same thing as arrow. So since if-then statements are so loosely used in the English language, there's a lot of ways we can express it, or a lot of ways they kind of appear. So the most common way, or the proper way to kind of do an if-then statement is, well, if, then the statement thing, then your other statement. So if a person is a father, then that person is a male. Now, confusingly enough, another way to say an if-then statement is Q if P. So we're kind of just reversing the order there, but notice that the order of my symbols is still the same. So a person is a male if that person is a father is the, well, it's not the exact same statement as above, but it's logically the same statement as above. Same with P is sufficient for Q. It's a very mathematical statement. So as Q is necessary for P. That's something that I kind of see a lot in my program. P only if Q, P. So these are all ways that if-then statements appear. I would say that we're only going to, at least in this course, kind of see those first two statements, first two types of statements. And really, I would be surprised if we even left or saw a lot of examples outside of just that first type of statement, just a clear if then. Now, another compound logic statement is if and only if statements. And so again, this feels like this feels like an if then statement, but it's not quite the same. And we'll see when things are true and when they aren't true in the next section. But this symbol looks very much like an if then statement, except for we have arrows going both ways. We say P is the same thing as Q. So in this case, the word is set. The word has 464 meanings. If we wanted to say the word is set if and only if the word has 464 meanings, we would do this arrow in both ways. And so we'll kind of keep hammering this point home. I'm not saying that's true. There might be some other word that has 464 meanings, in which case my if and only if statement might be false, but that's not what we're trying to do in this section. All this section is we're trying to represent different logical statements, different logical compound statements. So we could also do the negation. The word does not have 64 meanings if and only if that word is not set. So we would do tilde Q, arrows both ways, tilde P. And so in this case, order does not matter. So honestly, every compound statement we've seen in the section and or if and only if, all of those order doesn't matter. The only exception to that rule is if then statements. If then, the order is very important. So that's kind of why we have forward arrow, where in this case we have arrow going both ways. So we could write it in either way. So B, you could write tilde P, double arrow, tilde Q. Both ways are perfectly fine ways to represent the logical statement in B. So this is a nice table to kind of represent all of the symbols that we've seen in the section. Definitely something you should put on a note card. If you're going to make note cards, we have our negation, our conjunction, which is our and statement, our disjunction, which is our or statement, our conditional, which is the if then statement, and our biconditional, which is the if and only if. I don't write the exam, so I can't really necessarily promise this, but I don't really think we're going to use the weird words of disjunction and biconditional. Typically, we're only going to refer to them as the if and only if. If a question like this does come up on the exam, then you should ask me about it and say, what is biconditional again? I just didn't write it on my note card. Now, we can also have more than two statements. And typically, once we get outside of the statement, the single statement realm, we like to write parentheses so we can clearly see which things are related versus which times order doesn't matter. So we can have parentheses when we're dealing with logical statements. So let's see kind of an example of how to, in this case, we're actually going backwards, which is good practice, of taking something that is in symbolic form or their symbolic statements and translating it into something that we would say in English. So in this case, we have P is a student misses a lecture, Q is a student studies, R a student fails. And now we have these kind of bulkier statements of parentheses, Q, upside down V, tilde P, right arrow, tilde R, or implies tilde R. And so if we're going to translate that into an English statement, we would say if, because that's kind of overall what's happening, right? We have this parentheses on the left side, we have this arrow going to the right side. So we start by talking about our if then statement. So if, and then we go inside our parentheses, Q, or a student studies and a student does not miss lecture, then a student does not fail. Alternatively, here, my overall statement is this upside down V, my and. So I start by saying Q, a student studies, and then I go into my parentheses, tilde P. So if a student does not miss lecture, then tilde R, a student does not fail. That's kind of how we deal with these parentheses, and parentheses will become pretty important when we start to keep talking about this next section. We're building up to this idea of truth tables and building arguments. And when we have arguments, don't typically just make one statement and call it a day. Say a student missed a lecture and then they're not going to pass. That's true, but life's typically a lot more complicated than that. And arguments tend to be a little bit more complicated than that. And so we're going to have to kind of be aware that parentheses can happen and when we're grouping kind of these compound statements together.